How's the word break down? Try. What's that mean? Three.
Angles.
Gono. Angles? Maybe. Metry? Measure. Yes! Three-angle measure, right? Or triangle. Okay, so triangles, right? We're basically going to be looking at triangles. Now until the end of the course. All kinds of trig, right? So that timeline takes you right through to the very end. It is double-sided. Okay, it's got winter break in there. You can see you're going to get a measurement assignment handed out tomorrow, which is due on December the 17th. Okay, you can see that the trig quiz will be on Wednesday, January the 9th. We will then review for the final exam for a couple of days. Classes will end, and your final exam is in the main gym from 1 to 3 on Thursday, January 17th.
What is the measurement?
Okay, so today we start with right-angled triangles. Okay, there is a right-angled triangle ABC. There's a convention when we name triangles, and that is that angles are named with uppercase letters, and that the side opposite an angle is named with the lowercase letter of the angle it's opposite. So this side here is named what? Little a. This side is? And this side is? Little c. Okay, so angles, uppercase letters, sides, lowercase letters, and specifically, the side has the same letter as the angle which it is opposite. Okay? So what do you know about little a, little b, little c?
Hypotenuse. B squared equals C squared.
Okay, so one of the first things we learn about right-angled triangles is a squared plus b squared equals c squared. And various rearrangements of that, right? B squared is c squared minus a squared, and a squared is c squared minus b squared. And that's called what? Pythagorean theorem, right? Named after? Pythagoras. Okay. So that's the first thing we know about right-angled triangles, right? Is that the square of the hypotenuse is equal to the sum of the squares of the other two sides. We also have some primary trig ratios. Anybody know what they're called?
3, 4, 5.
Sine, cos, tan, which actually are sine, cosine, and tangent, abbreviated as sine, cos, tan. Okay, 3 letters, so the 3-letter sign is S-I-N, which is pronounced sine. Okay, if you're in a Catholic school, it's sin, but here it's cosine, C-O-S, and tangent, which is abbreviated T-A-N. And these are the abbreviations that are on your calculator. What mode does your calculator need to be in? Degree mode, right? Okay. So that's one of the things that's going to happen from this point forward. When your calculator is cleared, what mode is it in? Radian. What's a radian?
3 pi radians. 2 pi radians make a circle.
Okay. So a radian is just an alternate way of measuring an angle. We don't use it yet. I'm not sure. Do we do radians on here?
I don't think so.
Special angles in the unit circle. Yeah, it's probably saved for next.
No.
Next year, actually, not even next semester.
Radians are so useful.
Okay, so when your calculator is cleared, you're going to have to go into mode and set it to degree mode. All right. Now that only matters if you're doing trig. It doesn't matter if you're doing sequences and series. It doesn't matter if you're doing, graphing quadratic functions. But if you are doing anything with trig, it's got to be in degree mode. Okay. So you got to change it. During the exam, they should remind you. It should also say on the formula sheet or somewhere, calculators in degree mode. Usually they'll also say, because what will happen on the exam, which you only have to show up for exams, right? If you don't have an exam on a particular day, then you don't need to come. You can, and meet up with friends or whatever to study, but you can't bring stuff into the exam room besides your calculator, pencils, erasers, spare batteries, a ruler, highlighter. You're allowed like a clear, it's like flying, right? You get like a clear Ziploc bag you can put your stuff in. So having a little ruler, highlighter, etc., right? And your calculator, right? Which is a TI 83 or 84 family, because you're going to need that. Your calculator will be cleared by the teachers, unless you got one of the fancy ones, and then you'll show us you clearing it, right? Pushing the reset on the back or whatever it is that clears it. When it's cleared, then you can, as soon as it's cleared, you can set it to degree mode. They may or may not remind you. It may or may not say it on the formula sheet or the front of the exam. Either way, it's your responsibility to put it in degree mode. Okay. So we use sine, cosine, and tangent. Those are ratios. But before we do that, we have to learn the names of the sides of the triangle. What's the name of this side? Hypotenuse. And what's special about the hypotenuse? Hypotenuse. Okay, what are we going to say about the hypotenuse? Longest side. Longest side. Opposite the right angle. Okay, anything else? All right, we're good. Okay, so we have names for the sides of the triangle, right? But they're in relation to the angles. The hypotenuse is fixed, right? It's always opposite the 90-degree angle. When we are talking about the other sides of the triangle, we use the words opposite and adjacent, but it has to be in relation to a particular angle. So if we're talking about angle A, which side is opposite angle A? So little a is opposite angle A. And if we're talking about little b in relation to, so let's, on here, we'll say in relation to angle A. In relation to angle A, little a is opposite angle A, and little b is adjacent. And little c is the hypotenuse. Okay, kind of kick down here. In relation to angle B, little a is adjacent to angle B. Little b is opposite angle B. And little c is the hypotenuse. So your job, looking at a right angle triangle, I think your first step is always identify the hypotenuse, then look at the angle that we're talking about. If we're talking about a particular angle, then you look at that angle, then you can name the other sides, right? Opposite and adjacent. Because you'll notice that with relation to angle A, little c is adjacent to it. But little c is also adjacent to angle B. So we don't use that terminology, right? We can't have a side that's adjacent to both, right? So c, little c is the hypotenuse, right? That's a fixed name. Then we can name the other two sides opposite and adjacent. We do so in relation to one of the angles, okay? So you can't just say little a is opposite, right? It's in relation to angle A, little a is opposite, little b is adjacent, little c is hypotenuse. right? So that's right triangle terminology. Okay, let's move into the primary trig ratios. Let's go to a new page. Right angle, little a, C, B, clean this up. Okay, we have 3 primary trig ratios.
Trig ratios are so funny.
Yeah. Okay, so first one is sine. The sine ratio. What's the sine ratio equal to? You guys already know this. Opposite over hypotenuse, right? So the sine ratio is equal to the opposite over hypotenuse. So if we talk about the sine of angle A, since it's an angle, it's an uppercase letter. What's the sine of angle A? So I'll often just abbreviate it, say OPP, the opposite over hypotenuse. What's opposite angle A? Little a. What's adjacent? What's the hypotenuse? Little c. So the sine of angle A is A over C. Okay, opposite over hypotenuse. What's the sine of angle B? Okay, opposite angle B is little b, and the hypotenuse is fixed, right? That's little c. Sine ratio. What's the cosine ratio? Okay, so the cosine ratio is adjacent. When did you guys learn this stuff?
Last year,
Oh. Oh, right, yeah, this is the unequal class, right? Some of you have done it and some of you haven't. So. All right, so for those of you learning this for the first time, it's okay, you'll get yourself caught up, don't worry about it. So the cos ratio, which is abbreviated COS. So I say cos is adjacent over hypotenuse. The cosine of angle A is?
B over C.
Little b over little c. The cosine of angle B? Is opposite over hypotenuse.
Adjacent.
Right. Cosine is defined as adjacent over hypotenuse. Which is what?
A over C.
Now there's something else going on in this triangle too, right? What do we know about the measure of angle A? So what can I say about angle A plus angle B?
That's equal to 180 minus angle B
Or let's do it this way. I'm going to go back to the other page, right? So here, we'll just go back to the original triangle here. So when we were stating this, we could also say angle A plus angle B plus angle C is equal to 180, right? Because the sum of the angles in a triangle is 180 degrees. So what about angle A plus angle B? What's it equal to? Yeah. What's it equal to? 90. Right? If C is 90, then the other two angles must add up to 90. So that's going to work in any right triangles. What do we call angles that add up to 90 degrees? Complementary angles, right? So angle A and B are complementary angles. Okay, that's the word complementary. You just couldn't fit it in there. It's like you do when you're writing an English paper. You can't spell a word. Start it out right, end it right, jumble the middle. It's okay. They'll figure out the word. Right? And it's like, well, your writing sucks. No, my spelling sucks. I figured if I wrote it that way, you'd give me the mark. Yeah. Unless it's actually a spelling test. When's the last time you all had a spelling test?
Grade 2.
Yeah, okay. It's been a while. Okay, what do you notice about the cosine of angle A?
It's the same as the sine of angle B.
It's the same as the sine of angle B. What do you notice about the cosine of angle B?
Sine of A.
What does the co stand for? Or cosine, what's that mean?
It's the opposite side.
A coworker of sine.
It's cooperating side.
I actually can't spell the word, and now I have space.
Complementary.
What's cosine mean?
Cosine is condescending.
Are you sure? Complementary has a
Yeah.
Oh yeah.
What's cosine mean? It's the sine of the complementary angle. What do we know about A and B?
Complementary.
They're complementary angles. So the cos of A is the same as the sine of, and the cos of B is the same as the sine of. There you go. Right? Something you didn't know. Use trig ratios to calculate missing angles in a triangle. Yeah, so we're going to do tan ratio. Oh, right, sorry, tangent. Yes, finish off. The tangent ratio. What's tan?
Opposite over.
Okay, what's the tan of angle A? So we're going to call it OPP over ADJ, which is A over B. What's the tan of angle B? Okay, again, OPP over ADJ, which is B over A. Okay, so that's sine, cos, and tan. Those are the three primary trig ratios. Okay, what are the secondary trig ratios?
Sine.
No. Anybody? Probably not. Yeah. You're just saving that answer, right? Because it's not an answer to the question I asked, but you know, it's good. Here, let me show off some knowledge I have. I'm just going to randomly spit it out there. And it's actually trig related. So what are the secondary trig ratios? What are the other three trig ratios which are not sine, cos, and tan?
I know the name. I forgot.
Okay, you don't have to know them. It's not part of this course, right? Yeah. No, secant, cosecant, and cotangent. But
Oh.
don't worry, it's not part of this. You do not have to know this, right? Don't write it down. You know, but it's a good answer to a trivia question if you need it.
When will that ever be on there?
Using trivia. Okay, so moving on.
It'll be like who discovered
New page.
It'll be like Doc Pythagoras because some Chinese guy did it before
Okay,
God.
don't even care.
Okay.
So, what I want to know is, what is the Mohi, what's the mnemonic that we use to remember sine, cos, and tan? SOHCAHTOA, right? Okay. So remember that? So. Okay, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Okay? So, SOHCAHTOA. All right, what is the tangent of angle D? Okay, so let's start with tan of D is opposite over adjacent. What's the length of the side opposite angle D? 3. What's the side adjacent? Okay, now, here's a question. What is angle D then? So first of all, we can write this, right? So tan of D is 0.75. What's D? How do we undo a tan?
Oh, like 1 over 10. Yeah.
Not 1 over 10, but
6.8.
so if we do this, okay, so it's sort of like if I had the square root of x was equal to 9, then what would I do to both sides? I would square them both, right? I would square them to get rid of the radical sign, right? Now, you're never actually going to write this down, okay? But if you do the inverse tan to the tan function, what do you get?
The angle.
Yeah, you just get the angle, right? So the inverse tan, the undoing the operation that's being done here, returns to you the angle. So really all we do is this, right? We'll say D is the inverse tan. So you'll go from here to here, right? If the tangent of angle D is 0.75, then angle D is equal to the inverse tan, right? It'd be like squaring both sides, right? If you have the square root of x from this, then x is equal to, and you'd square it. Okay, what mode is your calculator in? What is the inverse tan of 0.75? 37, exactly?
No, it's 36.86.
All right, so let's go 1 decimal, let's say. So 30,
6.9.
okay, what's after the 9? 36.9 what? No, what's it say in your calculator? 36?
36.869.
869. Okay, good. So just wanted to make sure we're rounding correctly. So 36.9 degrees is the measure of angle D. What?
What is your calculator?
He operates on like a 2-minute delay, right? It's like things happen and then 2 minutes later it's like, oh, right. Which if you didn't say anything would be fine, you know. You can operate silently on a 2-minute delay. You're just kind of 2 minutes behind the whirls. When you say stuff, it's like, right? Then you admit to the world skills. It's got skills. Okay, what if I want to figure out angle F? Right, we already know angle E is 90, we're not going to do anything with that. So the tan of angle F is equal to opposite over adjacent, which is 4 over 3. So what's F equal to? Okay, so look, anytime, like 0.75 is exact, right? 4 over 3, you're not going to get an exact, you can't type it in exactly. So just type it in as 4 over 3. Do not go and say, oh, it's 1.3, because that'll give you the wrong answer. It's 1.33, wrong answer. No. You either got to hammer in a whole pile of 3s, right, or you just say it's 4 over 3. Okay. So what is the inverse tan of 4 over 3? 8.1. 8.1 degrees.
53.1.
Sorry? Oh. What do you guys say? What am I hearing? Because what do we know about those two angles? They got to add up to 90. Right? And they do. Hey. Okay? So really, if you work this one out, you can just calculate this, right? It's just 90 minus that. Right? But we just want to see the tan ratio in action. Hey, look at that. Really is, you know, really works. Wow. Okay, cool. Okay, so we're done anyways. Angle of inclination. So there are 3 types of angles we need to learn the names of as set forth on the outline. Angles of inclination, angles of elevation, and angles of depression. Depression. Yes, they're the sad angles. This angle is sad. So an angle of inclination is something that we would use if we were measuring the angle that a roof makes, right? If you're looking at the angle, you'll cross the street there, you see the houses, and you see that roof. It's on an angle, right? So measuring from a horizontal line at the base of the roof up through this angle in here is the angle of inclination, right? It's the incline of the roof. So here's the incline. Same thing for a ramp, right? So if we're looking at a wheelchair ramp or something like that, there's a certain angle of incline. And then there's a building code that tells you what the angle of incline can be, right? I mean, because you need things to be able to get up in. What else inclines? Ladder, right? So a ladder leaning up against the wall would incline against the wall, right? What else?
A ramp.
A ramp. Said that right. What else? Stairs. You could measure, right? So if you laid a flat object on the stairs, there'd be a certain angle the stairs make.
I know.
And again, there's a building code that tells you how steep you can make a set of stairs, right? So in a public building or in a house, maybe you can get away with a steeper set of stairs. If you're looking for stairs going up into an attic, they're seldom used. They could be at a steeper angle. Okay? Also, angles on roads. So you'll see a road, you know, and there's a slope coming up ahead. They'll give you the angle of that. A ski slope. What's the angle of inclination of the ski slope?
90
Give it
degrees.
as a percentage. There's like a slope on the road.
Yeah, they give it as a percent, but you can also give it as an angle. So more likely, the engineers that design it at a certain angle or for a certain slope, right? But what's the definition of slope? Rise over run. What's that angle there? It's the angle of inclination. How is it related to the slope? Slope is? So what's the slope then? It's really just it's the tangent ratio, right? It's opposite over hypotenuse. So when you're working out the slope, right, you're really getting the tangent ratio. If you wanted to know the angle, you would just do an inverse tan on your slope. That would give you the actual angle, right? Damn this math, it all ties together. Okay, so if you want an angle of incline of a roof, now here's the thing, if you wanted to put a solar panel on a roof, and there are programs to do that, NMAX has a program out with that, you know, they'll put a solar panel on there and you can tie into the grid, and if it's a really sunny day and you're not using much electricity in your home, then your meter can run backwards, because you're actually putting electricity into the grid. And then if you're drawing it out, then it runs forwards, right? But yeah, the payback period is only about 120 years. No, I'm not sure what the payback period is. It depends on, you know, as the cost of solar cells comes down, and this is energy that really would just go to waste, right? I mean, it would just heat the ground or something. So if we can turn it into usable electricity, then that's kind of a neat thing. Ideally, for the angle of a solar panel, you want the angle of inclination, that is the angle between a horizontal line and the roof, to be approximately equal to the latitude at which the house is at, right? So you can figure out what latitude are we at, and that sets the angle of inclination you would like the roof to be in order to maximize your collection of solar energy. Okay. Now, you know, if this is a field you go into, you'll of course learn all this stuff, right? But that's just where we sit now. So let's say that I have, let's do this, the latitude of Fort Smith, NWT, is approximately 60 degrees. Determine whether the design for the solar panel in the diagram shown, or in the diagram soon to be shown, is the best for Fort Smith. It's a real-time question, so the diagram has yet to be shown, but now I'm going to show you the diagram, and then you can. Soon to be shown. Shown. Okay, so there's a house up in Fort Smith. There's the roof of the house. There's the solar panel on the roof of the house. They're on the other side.
They have no door going to the backyard.
Side of house, no doors. You don't have doors on every side of your house.
You don't have to have doors, you just jump out the window.
I got a door on the front of my house and the back of my house, nothing on the side. Okay, what are we gonna figure out?
2 doors if you want to have.
So here, let's isolate the triangle. Let's call it ABC, just to switch things up. This is 9, this is 12, that's your right angle. What do we need to find? Which angle?
Angle C.
Angle C. What do we want angle C to be?
60 degrees.
60 degrees. If angle C is approximately 60 degrees, then we know that we're at the optimal. We can use it like 6 months a year in Fort Smith. It's dark half the time. You know, at least here it's only dark a third of the time. Yeah, we are a sunny city, so Okay, so what are we gonna do? What am I gonna write?
Tangent of C is equal to opposite over adjacent.
It was like formulas, right?
Is equal to 9 over 12.
So we could say little c over little a. Tan c is 9 over 12. What's c?
Tan is 1.
Yeah. You know what? Don't bother working these out. Right? There's no point in working. There's no point in simplifying. There's no point in working it out. Right? We're just going to do an inverse tan, 9 over 12. Which is?
Our number.
How many degrees?
64 degrees.
How much?
36.9 degrees.
We did this one, didn't we? Yeah. Alright, so we're going to say approximately equal to 37 degrees. Is that a good fit for the solar panel?
No.
No. So if we were going to put it on there, we'd want to angle the panel, right? We want to put something there to angle it up differently, okay? So if you're going to install it. So a solar panel installer would know this, right? Working in Calgary at a what's the latitude of Calgary?
I don't
51.1.
Yeah, something like that. It's pretty close. So it's around 51 degrees, right?
Trivia.
Seriously, isn't it? That'd be more impressive if you whipped up your GPS. Oh yeah, go ahead. All right. Our current latitude right now in this very spot. Somewhere I have GPS at.
The powers of reading.
Yeah, exactly.
I can't. I don't have that ability.
GP spot. Scan. 50.98649 latitude, where we are. Altitude 3,500.66 feet. I can change that again. Meter. Measure. We'll measure in metric.
Metric.
Yay.
That's my eyeball.
Yeah. All Alright, 1,067 meters. Longitude 114.035 west. Okay, within plus or minus 26.95 meters right now. It'll still scan though, and it'll like battery dry. I'm going to actually close it. Sometimes, like, why is my phone so high?
Because it's
You left your GPS app going and it's constantly scanning and using up battery power and it gets hot. Alright, so this is not a good angle, right? So, not a good angle for this solar panel. No, the good angle is 60 degrees. So if you look, are there any solar panels in your neighborhood? Do you see any mounted on roofs?
No.
Okay. So next time you go by, if you have a look and see, are they flat on the roof, or is part of it, do they have little support? So maybe it's, say here's the roof. Is it like this, so that there's a little support at the back? Or let me ask it this way: is the angle of the panel the same as the angle of the roof, or have they changed? Okay. So anyway, start noticing that and then see, right? And then you could figure out the angle of the roof, and you could knock on their door and say, hey, really, you get a better, if you angled it at 50 degrees instead of the current angle. And they'll say, who are you? Why are you here? So I'm just trying to make trying to make the angle a little more efficient here. Okay, so what are you going to do? Ideas? What are you going to do? Draw a diagram, right? So, if in doubt, draw a diagram. Other thing you're going to do is you're going to note that when you solve this, you're going to round the angle to the nearest degree, right? Because you're tired of losing marks on numeric response because you didn't read the what should I round this to, okay? Or you rounded incorrectly. Medical problems? Issues? No? You probably can go. Okay. Okay, how's that?
The ladder is 10 feet. Not the other.
So, what's wrong?
You don't know.
Oh, the 10 feet is supposed to be on the ladder.
Yes. Ha ha ha, you can't take it. Yeah, but great dude.
Okay. Now what?
What angle does the ladder make with the ground?
Which would be called the angle of inclination.
I just read the question.
Right? The angle of inclination. Okay, how are we going to figure this out? So the next thing we ask ourselves is, what sides do I know? What are the names of the sides we know?
Hypotenuse and
Keeping in mind, what do we want to find, right? We want to find this angle here. What's the name of this side? What's the name of this side? Which trig ratio relates? So if we want to use tan, we're going to have to use Pythagorean theorem and figure this out, right? But then, do we need to?
no.
Which ratio do we know uses opposite adjacent? Cosine. So the cos of angle A is equal to adjacent over hypotenuse. The cosine of angle A is equal to what? Numbers? Angle A is equal to what? Don't bother simplifying, right? You do that, you end up messing up because you get, like you just do it in your head wrong. Okay? I mean, you better not with 4 over 10 and 0.4 is 2 over 5, but just put it in the way it is with the numbers that are there. There's no point in simplifying. Okay? What's angle A?
66.4.
Okay, 66. Okay, and what are we going to write? Rounded to the nearest what? To the nearest degree. Read the question. Okay, so that's an angle of inclination. Now, if there were an observer lying on the ground here looking up, it would be called an angle of elevation. So an angle of elevation is an angle measured from the horizontal. So usually it's me. An angle of elevation is usually a person looking, right? So you get a horizontal line and then you look up and that's your angle of elevation. Okay, so angle of elevation if I'm looking up. So let's say that I'm on the ground, I'm looking up because somebody's on the roof. I'm like, what are you doing up there on the roof? Right? I'm probably pointing up at the angle of elevation. Right? It's horizontal line, angle of elevation. And they're standing up there pointing, what are you doing down there? What kind of angle do we call that? That's an angle of depression. It's measured from the horizontal down, right? So this is an angle of depression. It's from the horizontal. It's you're looking down. So I'm looking out. Here's horizontal line. I look down. This angle in here, right, is your angle of depression. It's equal to the angle of elevation of the person looking up. Right? So if you're in a scenario where you know the angle of elevation, you also know what the angle of depression is. It's just measured in a little different place. So let's do a diagram so we can show what those look like. So let's talk about angles of elevation and depression.
I got it, damn it. I'm not stupid.
Okay, here's a building on the ground. This angle here is the angle of elevation measured from the horizontal line up. Right, so angle measured up from a horizontal line. Okay, so that's your angle of elevation. Your angle of depression is this angle in here. Do you know the angle? Okay, that angle in there. It's measured down from a horizontal line. So angle, it's outside the triangle, right? You notice if we're talking about this triangle here, the angle of depression is not inside the triangle. It's not in here. So angle of depression. measured down from a horizontal line. Okay, so those are angles of elevation and depression. Okay, they are equal to each other. You know about, because these are parallel lines, and you got that unique little Z shape here. So these angles are called alternate interior angles, and alternate interior angles are equal. Okay, so the angle of elevation is equal to the angle of depression. So if they give you an angle of depression, it's not inside this triangle, which usually we're trying to solve. You immediately know that, oh, well, that angle there is this angle down here, and that's a 90, and I know that this and this have to add up to 90. Why? Well, because this and this have to add up to 90. Huh? Right? Okay. Anyways, you'll figure it out. You're all pretty good.
Got it. Triangle of elevation equal to
Huh?
okay, triangle of elevation equal to depression.
Yes. So if you're on the ground looking up at this helicopter flying overhead, and they're looking down at you, shining the light, looking for somebody who shouldn't have done what they did, but they're up in the air, then that's the angle of depression. You could say, it's not me. I didn't do it. Don't run from the helicopter.
I'm finished.
Okay, so now we got to talk a little bit about sine, cosine. Well, we did a sine one. Oh, sorry, we did a cosine one, right? So let's do a sine one, and just we'll figure it all out here. All right. So do I need to do an example of sine? No, probably not. I will just do one nice practical type example. Find a little angle here, and okay. So. Here's a cable. Okay, there is a 100-meter long cable, and it's running from the ground to the top of a tower or building, right? It's going to hold that thing. So, and there's another cable on the other side as well. Okay, and this is let's say it's a cell tower. And we want to find theta. What's theta?
It's like a circle with a line.
Yeah, Greek letter.
Greek letter. Theta is to trig as x is to algebra. Although I don't know if there's a video on why theta. We know why x is used because there's no sound in Spanish, right? But theta. So theta is your common unknown, right? If you have an unknown in trig, you use theta for an angle, right?
So
Unknown
what
angle.
happens if you have more than one? Alpha, beta.
Then you can go to alpha, beta, gamma, delta, and pi. And don't use pi. Don't use pi. Okay, so I want to know this angle, and I've got this cell tower. How high is this tower?
10 meters.
I don't think you can use a 100-meter cable to anchor it.
450 million.
Yeah, okay, I don't think it can be over 100 meters tall because a 100-meter cable won't reach the top of a tower that's 100 meters tall other than going straight along. 80. All right, I'll go with 80. So look, part of solving problems is look back. So, I remember one year, many years ago, grade 10 test, and I just asked about, a 12-foot ladder is leaning up against a wall at an angle of blah. How high up the wall does it reach? And so I put an answer, it was like 15 feet. I think, well, okay, if I got a 12-foot high ladder, what's the highest up the wall that it can go? 12 feet, right? Just push it flat against the wall. I wouldn't advise climbing it at that point, but unless it's mounted to the wall. But it can't go 15, right? So part of every question is look back. Right? Does this answer 15? Does that make sense? I mean, they flipped a couple of numbers around and got a number that was way bigger than it should have been. So look back, right? Because you're going to do it. Okay, I did that. I carried out the calculation. I plugged it in my calculator, which happened to be in radian mode, and I got 15 feet, and I just ran into the ladder just 15 feet of wall. Okay, which I just found like, really? Did you think about this? All right, how do we find theta? Okay, so sine theta is opposite over hypotenuse.
No, it's not
Theta. theta. Some pronounce it theta. I'm not Greek, I don't know. Any Greeks in here? Anybody speak Greek? You have a Greek friend? Ask him how it's
I'll
said.
eat Greek yogurt.
I went to Greece upside down.
That's an always living
All right, nearest tenth. What is it? When the angle is? Don't bother simplifying, right? Who cares? Just do it as 80 over 100.
I beat you.
53.1 degrees.
You didn't even know the answer until you looked at this.
If somebody happened to be on top of the cell tower looking down the cable, the angle of depression would also be 53.1 degrees. Okay? All right, now, very important thing, or piece of information. When you're doing the questions, use this, okay? Because we're not doing every question. It's tan ratio, it's 3, 4, 5 AC, 7, 8, 10 AB, etc., right? Because tomorrow, lengths of side, so we're not doing every question, we're not necessarily doing them in order. We might do some now and some later. So follow this, which is good advice for any of our outlines, right? We don't always do things in the exact order or way that the book does things, or whatever we're taking the questions from. So make sure you, otherwise you're gonna get the hand will be out and be like, I don't know how to do this question. Yeah, of course you don't, because we haven't learned that yet. It's tomorrow. So don't do it, right? And then you get all embarrassed, right? Oh, sorry. So,
Why
anyway.
exactly? This unit is so long.
Well, we gotta end the year somehow, and this is it.
Big booklet.
Yeah, big book, big bang.
But big day starts it, not does it end it.
I don't know. Haven't got it yet. When I get it, you'll get it. Well, tomorrow you'll get it. So. Oh, okay. I'll tell you.